A very good morning to all of you. So we are going to start our today's lecture that is on the Zener diode. So you know that the Zener diode is a special type of diode, and in this diode the doping level is very high as compared to the PN junction diode. Now the Zener voltage is 6 voltage. Now this voltage is having a constant value, and you can pass any current through a Zener diode, but Zener diode will be having certain limits, that is the knee current and the maximum current. You might have already studied about the knee current and the maximum current. So if you draw the the VI characteristics of the Zener diode, then you know that this Zener diode will be operating only in the reverse bias condition. So in that case, you see this is the Zener breakdown voltage. At this breakdown voltage, the electric field is very high, which is sufficient to dislodge the electron from their covalent bond. Now this one is the knee current, and so you can pass this current also, and this one is the maximum current which you can pass through the Zener diode. So we can write this current as IZ max. So now in this question, what is given? Zener voltage is 600 volt. Now a simple circuit is there. You are having the input voltage of 10 volt. Then a 1 kilo ohm resistance is given and 1 kilo ohm resistance. Now you will have to find the output voltage. So you can simply apply a Kirchhoff voltage law in the outer loop. So when you have applied the Kirchhoff voltage law, so what you are going to get, you will get a simple circuit. Now in this case, you will have to check the state of the Zener diode, whether it is in the breakdown region, or in the normal region. So this one is 1 kilo ohm, then you are having this 1 kilo ohm resistance. So you can see here a simple circuit is there. So 10 volt, 1 kilo ohm and 1 kilo ohm. So here you can apply Ohm's law. So V will be equals to what? I into R. So in this case, I will be equals to V upon R. Now V will be equals to 10 volt, and this one is 1 plus 1. If you add the value of two resistances, it will be 2 kilo ohm. So in that case, you will be getting I will be equals to 5 milliampere. Now, if you have to find the voltage across this resistance, so V0 will be equals to what? That is 5 milliampere into 1 kilo ohm. So in that case, it will be 5 volt. Now you can see the voltage across these 2 points will be 5 volt only, and this the same voltage is appearing across your Zener diode. So what you can say, you see the Zener voltage is 6 volt, but the voltage which you are getting across the Zener terminals will be 5 volt. So in that case, if it is 5 volt, it means that the breakdown has not reached. We can say the Zener breakdown has not reached. So this is all about this question. So we'll take one more numerical. So we are going to take our next numerical, and in this numerical, Zener diode is given. The Zener diode of 5 volt is given. It means that when this voltage will be reached, the Zener is going to provide you a constant voltage irrespective of the load current, or you can say irrespective of the load current which is flowing through the Zener diode. It means that, but you will have to check whether the operating current is between the knee current and the maximum current. Now in this problem, the knee current is given, and that is 10 milliampere. You can see here. So what is the knee current? If you draw the VI characteristics of the Zener diode, my drawing is not that much clear. So if you are going to draw the knee current, so in that case, this is the minimum current which can pass through a Zener diode. This is V, then the current, and this one is the minus VZ. So when this breakdown voltage will be reached, this is the knee current which you are saying, that is IZK. Now this is the minimum current. So when you see that the minimum current is flowing through the Zener diode, it means that there will be a maximum current through the load resistance. And when the load current is maximum, so there will be a minimum value of the RL. So you will have to find the minimum value of the RL only. Now When the Zener breakdown voltage has reached, it means that the voltage which is appearing across Zener will be 5 volt only. And this 5 volt will be coming across your load resistance. It means that the same 5 volt will be coming here, that is 5 volt. So now your breakdown voltage has just reached and the minimum current is flowing through the Zener diode, that is 10 milliampere. And first you will have to find the I load current value. But for finding the I load current value, you will have to find the I current. Now how you are going to find the I current? You can see you are having this 10 volt. This 10 volt is there, then you are having this resistance that is of 100 volt, and the Zener diode of 5 volt is reach of 5 volt is there, that is 5 volt. So if this value is 10 volt and if this value is 5 volt, it means that the 5 volt is going to appear across your 100 ohm resistance. Fine. So now you can easily find the current value when 5 volt is there and 100 ohm is there. So I will be equals to what? I will be equals to 5 upon 100, and that will give you the value 0.05 ampere, or you can say it will be 50 milliampere. So 50 milliampere current is flowing from the 10 volt source. So now this current is 50 milliampere and the knee current is 10 milliampere. So you can easily find the load current value, and that is 40 milliampere. So when the load current is 40 milliampere, and this minded that this value is the maximum load current, so you can easily find the RL minimum, and RL minimum will be equals to that is 5 volt. 5 volt is constant because your Zener diode has reached the breakdown voltage. So 5 upon 40 milliampere. So in this case, you will get the value of the RL minimum. So now the next part is the maximum power rating. Please make the correction, that is maximum power rating of the Zener diode. Now what is a maximum power rating? So when you are talking about the maximum power rating, that time you will have to take this formula. P max will be equals to, you know that the voltage is constant, but you can pass the maximum current through the Zener diode. So in that case, it will be Vz into Imax. But you will have to find the Imax value. So how you are going to find the Imax value? So in that case, you will have to say that the maximum current should flow through the Zener. It means that there should be a minimum current. Now, what is the minimum value of the current? What is the minimum value of the current which can flow through the load resistance? Any guesses? I think it should be 0. It means that the entire current of 50 ampere will pass through the Zener diode. So in that case, it will be 50 ampere. What is the maximum current which can pass through the Zener diode? It will be 0, we can say 0 ampere. So this will be 50 milliampere is a maximum current. So simply that will be 5 into 50 milliampere. Now this will be volt. So you are going to have 250 milliwatt of the Zener diode. So the power rating of the Zener diode is 250 milliwatt. So this is all about the Zener diode. If you have any queries, you can always ask me.